Hoover High School, this is AP Chemistry, and this is lesson number 12 on stoichiometry. It's the first in a series of lessons in stoichiometry. What is stoichiometry? Stoichiometry is the process, you can think of it as the math, by which we take measurements that we make in a laboratory, which would be in grams from a scale, or in liters of volume of a gas, or in the concentration of a solution, and we convert those into the only thing that a chemical equation understands, which is numbers of molecules, or as we generally deal with now, numbers of moles. That's simply molecules or atoms times 6.022 times 10 to the 23rd. So we usually speak in terms of moles now, these big baskets of molecules that we are able to work in. So chemical equations only understand moles or numbers of moles, numbers of molecules. So we need to take these types of measurements we do in the lab and convert them, and then once we've done what we need to do inside the chemical equation, we need to take that number and come back out into a number of grams or number of liters or some sort of a solution. And that's what stoichiometry is. So we're going to have our introduction to that in this lesson. Okay, so this busy slide kind of gives you an overview of what we're doing. So let me just go over it briefly. We're not going to do all of this today. We're not going to do all of this week. What we're going to do is cover these probably in successive weeks, over a few weeks. So up at the top you see our world. That's the measurements that we can make in a laboratory. So we measure in grams, liters, and molarity. We'll talk about molarity later on. We need to convert to moles. So if you look there, if you have a pure substance, such as a known gas that's a pure gas, say helium for example, or neon, then that would be a known gas, or a liquid such as pure water, or a solid such as could be gold, it could be carbon, or it could be some solid compound of some sort. If you know what it is and it's pure, then what you can do is take the molar mass or calculate the molar mass of that substance. And that will allow us to convert from grams to moles. So the molar mass is our translator. If you speak a language that's different from someone else, and you don't both speak the same language, then you need a translator, somebody who speaks both languages to help translate for the two of you. So we need a translator to get us from grams to moles, to get us into the equation down there at the bottom, the chemical equation, and then to get back out of the chemical equation back into our world of measurements of grams. So we call that chemical world down there. It's inside the blue box. In order to get into that blue box, you have to be in moles. Those numbers in the chemical equation at the bottom are expressed in numbers of moles. That is, numbers of molecules or atoms. And that's what you have to be in to use that chemical equation. That little animal, by the way, is a mole. That's what a mole looks like. Okay, so you look at this. We're going to isolate just one part of this. So there's our world up on the top, and there's chemical world down on the bottom. So we work in grams. The chemical equation works in moles. So we do that. We have the pure substances there. We do a molar mass conversion, and that gives us a number of moles that allows us to go into the equation, and then similarly allows us to come back out again later on. So that's what we're going to focus on, is grams to moles conversions in this lesson. Okay, so here's our first question. And you see there's a graphic organizer. Let's go over that. It looks somewhat similar to what you just saw. So there's the chemical equation down at the bottom. And up at the top is our world. And if we have a number of grams, we're going to put it into one of those boxes up there. If we have a number of moles, we're going to put it into the boxes in chemical world down there at the bottom. And the conversion between those two, the translator, is the molar mass of each of those substances. So you see the molar mass for methane CH4 is 1 mole is 16.04 grams. For oxygen, O2, is 1 mole is 32 grams. So you're not multiplying the molar mass. The molar mass is for 1 mole. So even though in the equation you have 2 moles of oxygen, that's not what you're putting for your translator. Your translator is 1 mole equals some number of grams. It's always set to 1 mole. So over there in carbon dioxide, 1 mole equals 44.01 grams. And for water in the far end, 1 mole equals 18.02 grams. But by the way, where did we get those? Well, we did that a few lessons back. How do you get those numbers? So water, for example, has a hydrogen at 1.01 grams, a second hydrogen at 1.01 grams, and an oxygen at 16 grams. If you add those three numbers up, you get 18.02. So you get those numbers straight off the periodic table, and then you add them up. Okay, so what we're going to do is use this graphic organizer to kind of see the flow of our equation. So how many moles of CH4? Let's start with that. That's in the red box down there on the bottom left. That's the question mark. It's moles of CH4, so we're inside of chemical world. We're inside where we deal with moles. And it says how many moles are required to form 8 moles of H2O, of water. Okay, so what we're going to do is we need to find a connection between moles of CH4 and moles of H2O. So there's the 8 moles of H2O over there on the right-hand side. Now this chemical equation flows from left to right. It goes from CH4 plus O2, 2O2, gives you 1 CO2 plus 2 H2O. So the chemical equation goes from left to right. But you can see how the math here, you always start with what you know. We know 8 moles of H2O. And the arrow is going backwards because we're trying to find out how many moles of CH4 would be required to create those 8 moles. But when we set the math equation up, we're going to put the 8 over on the left-hand side. So there it is, 8 moles of H2O. Whatever you know, you put on the left side whenever you write a math equation. And then what we're trying to find out is on the right side. There it is, some number of moles of CH4. And so we need a conversion. We need to find a relationship between H2O and CH4. And what is it? See if you can spot what that conversion would be. So what it's going to be is this. 1 mole of CH4 equals 2 moles of H2O. That's right out of the equation. We're not concerned with O2 or CO2 in this problem, so it's just that 1 mole of CH4 is going to produce 2 moles of H2O. And it's really a ratio. For every 1 mole of CH4, you'll get 2 moles of H2O. So if you had 50 moles of CH4, you get 100 moles of H2O. If you had 1,000 moles of CH4, you get 2,000 moles of H2O. It's a 2-to-1 relationship. All right, so now what we have to do is we have to take that conversion factor up top and turn it into 2 ratios. And you remember how we did that? You just put one over the other, or you flip it. You put the other one over the first one. So those are both true statements. The first one says 2 moles of H2O for every 1 mole of CH4. And the second one you would read 1 mole of CH4 for every 2 moles of H2O. Those are both true statements. But only one of them is going to help us in this problem. We need to have moles of H2O cancel out because it's not in the final answer. And we need to have moles of CH4 appear because it is in the final answer. So which of those two are you going to choose to put in that blank space up there? In the box up there. Which one goes there? And it's going to be this one. Okay, so we're going to go ahead and put that one up there. So now you have moles of H2O cancels with moles of H2O on the bottom. And the only thing you have left, the last man standing, is the moles of CH4, which is what you want in your final answer. So now that we have the units set up properly, we can now calculate the numbers. So you have 8 times 1 on the top. Everything on the top you multiply, divided by everything on the bottom. 8 times 1 divided by 2, and that equals 4. So you have 4 moles of CH4, and you can go ahead and put that down in the box at the bottom if you would like. There it is, 4. So if 1 mole of CH4 produces 2 moles of H2O, then 4 moles of CH4 will produce 8 moles of H2O. Now you may say, well, that was easy. You could have done that one kind of in your head. But believe me, you're not going to be able to do most of these in your head when we get into more advanced areas of chemistry. So you need to learn this technique to do this, okay? All right, let's go on and try one now with 2 conversions. You're going to need 2 conversions to do this problem. So the question is, how many moles of CH4 are required to form 3.2 grams of H2O? So we're starting with grams of H2O. That's our world. Okay, we measure things in grams on a scale, and you see it up there in the right-hand box, upper right-hand box, 3.2 grams. and it's in our world of grams. So that's where we're starting from. That's the thing we know. The place we're trying to get to is how many moles of CH4, is moles of CH4. And that's down there in the bottom left, you see in the red box with the question mark. So what we need to do is find a path that gets us from 3.2 grams of H2O to some number of moles of CH4. So how do we do that? The first thing we do is we go through the molar mass to get into the chemical equation. So we have to convert from grams of H2O to moles of H2O. And we go, and then that will put that number in that box right there when we do that. Then you need to go across the equation from moles of H2O to moles of CH4. And that will be our final answer. So you can see it's a two-step process. So now we've started to write the equation up above. When you write an equation, what you know, what you're starting with is over on the left, and what you're trying to find, which in this case is moles of CH4, is over on the right. So we're going to need two conversions. We just said that. So let's go ahead and do this. So the first thing we're going to do is use the molar mass of water to get us into the equation from 3.2 into some number of moles. So we have 1 mole of H2O equals 18.02 grams of H2O. That's our translator that gets us from grams into moles. So you can create two conversion ratios out of that. Those are both true statements. Only one of them, though, is going to help us with the problem. So which one are you going to use? You need to use the one that makes grams of H2O cancel out. You have 3.2 grams of H2O, but grams of H2O doesn't appear in your final answer. So you need that to cancel out. So you're going to use this one. We're going to go ahead and place that up there. And now you can cancel grams of H2O with grams of H2O. Now, we normally don't do intermediate computations or calculations here, but I'm going to just so you can see how the equation is following the graphic organizer down on the bottom. If you multiply 3.2 times 1 and divide by 18.02, you can see down in the lower right-hand corner red box, you end up with 0.18 moles. Again, normally you wouldn't make that calculation. It's in the middle of the problem, but we're doing it here to demonstrate how the equation flows with the diagram down below. Okay, now we're ready to go from that 0.18 moles of H2O to some number of moles of CH4. So we need a conversion for that. What's the conversion for that? Well, it's the same one we had in the last problem. 1 mole of CH4 equals 2 moles of H2O. So from that, you can create your two ratios. Those are both true statements. Which one do you want to use, though? You need to make the moles of H2O in that first conversion over on the left cancel out, and you also need to make moles of CH4 appear on top for the final answer. So which one are you going to use? You're going to use this one. We put that up there, and we cancel moles of H2O, moles of H2O. Last man standing is moles of CH4, which is what's in your final answer. So that means we've set everything up properly. Now what you do is you go through and multiply the numbers. Everything on top is multiplied divided by everything on bottom. So 3.2, you notice the red boxes there, times 1, divided by 18.02, divided by 2. And when you calculate those, you get the number 0.094. And that is your final answer. You can go ahead and put that down in the red box above CH4 down there in the chemical equation. So that's how you do that conversion. That's how you set that up. Even more complicated conversions are done the same way. They just have more intermediate steps. So now let's go ahead and let's see one that has 3 conversions. And that's one that you're frequently going to be doing in class. Alright, so now the question is how many grams of H2O can be formed from 5.2 grams of CH4? So we're going from grams to grams. So let's go ahead and set this up. You have 5.2 grams of CH4. It's in the CH4 column up above CH4. But it's in our world. It's not in the chemical equation. It's in the world of grams. That's what we work at. Now we want to know how many grams of H2O. So over there on the right-hand side, you notice that question mark popped up in the grams row in our world for H2O. So you want to get from 5.2 grams to that question mark. So you might ask, can you just go straight across from 5.2 over to the question mark? And the answer is no. The reason is we don't know a direct conversion from grams of CH4 to grams of H2O. Let's say I gave you a box of pencils and a box of erasers and said, take the mass of the box of pencils, put it on a scale, and figure it out. And you say, okay, it's 500 grams. Those pencils are 500 grams. Okay, then I said, well, do a conversion now from that 500 grams to the mass of the erasers. How do you convert that mass of pencils to mass of the erasers? And you'd say, I don't know, I can't do it. You can't, because you don't know a relationship between the mass of the pencils and the mass of the erasers. There's no connection, no relationship. If I told you that the pencils had twice as much mass as each eraser, that would be a relationship you could use. Or I said that each pencil was 1 gram, was 2 grams, and each eraser was 1 gram, then that would also give you a relationship that you could use to convert and figure out what the mass is of the box of erasers. But you don't have any such relationship here. So here's the path we have to take. The only relationship we have between CH4 and H2O is inside the chemical reaction. So we're going to have to go through the chemical reaction to make that trip. So here we go. We start at 5.2 grams and we go down through the molar mass, using the molar mass to convert from grams to moles. And that's going to get us inside the chemical equation. We're now in chemical world because we've converted from grams to moles using the conversion 1 mole equals 16.05 grams for CH4. Now that we're in the chemical equation, we can move across and convert from moles of CH4 to moles of H2O. And that will get us over to that box on the lower right hand side. Now that we have that, we can come back out of the equation into our world using the molar mass of water. 1 mole equals 18.02 grams of water. And that will get us up to that box with the question mark. So it's a 3-step process. Our world into the chemical equation, across the chemical equation, and back out of the chemical equation into our world. There. So let's go ahead and start writing our equation up top. So there we go. On the left, we have 5.2 grams of CH4. And over on the right, we have unknown number grams of H2O. That's what we're trying to find out. The type is a little bit small because this is going to be a 3 conversion problem. There you see the 3 boxes right there. So it's going to get a little busy up there. All right, so let's go ahead with our first conversion. We need to get from 5.2 grams to some number of moles of CH4. And we use the molar mass. 1 mole equals 16.05 grams. So there it is right there. Now we can create our 2 ratios out of that conversion factor. Those are both true statements, the 2 ratios, but you can only choose one of them to solve this problem. Which one are you going to choose? Well, at the beginning we have 5.2 grams of CH4. Grams of CH4 does not appear in our final answer, so we need that to cancel out. So we're going to choose the one that makes grams of CH4 cancel out. It's that second ratio right there. We're going to put that in. We're going to cancel grams CH4, grams CH4. And at this point, what we would do is just continue to write the equation, but I'm going to show you down in the graphic organizer down in the chemical equation. That would be 5.2 times 1 divided by 16.05. That would give you 0.29 moles. Normally we don't do these intermediate calculations, but I'm doing it to demonstrate how the equation flows with the graphic organizer down at the bottom. Okay, now we're ready for our second conversion. We have to convert from moles of CH4 and move across the equation to moles of H2O. So how do we do that? Well, we've already done it twice in the previous 2 problems. 1 mole of CH4 equals 2 moles of H2O. So we can create 2 ratios out of that. Now, which one is going to go in the box? In the first conversion, you still have moles of CH4 sitting up there on the top, and that does not appear in the final answer, so that has to cancel out. So which one makes moles of CH4 cancel out? It's this one. You go ahead and put that in the equation there. Moles cancels with moles. And now if you run the numbers to that point, you'll get 0.58, 0.58 moles of H2O. So that's what you have that far through the equation. Now we're ready for our final conversion. We need to go from moles of H2O back to grams of H2O. That's what our question's asking us for. So we need to use the molar mass conversion for water, which is 1 mole equals 18.02 grams. So there's the conversion up above. create the two ratios. Which one are you going to use? Which one makes moles of H2O cancel out and grams of H2O appear in the final answer? And of course it would be that one. So we put that up there. Moles cancels with moles. And the last man standing is grams of H2O, which is what we want for our final units of measure in our final answer. So we can now go ahead and do the calculation. So watch the red boxes up at the top in the equation. So 5.2 times 1 times 2 times 18.02 divided by 16.05 divided by 1 divided by 1. And when you do that calculation, you get 2.9 grams of H2O. And you can go ahead and put that in the red box there at the top. So this is how you do this. There's a fancy name for this. It's called dimensional analysis. You don't need to know that. It just means lining up your units of measurement so that they line up properly. And once you have them lined up properly, then you can run the numbers. You know you have your numbers set up properly. All right, so that takes care of gram stoichiometry. We're going to do a couple of more subjects this week. That will be limiting reactants and empirical formula that deal with this subject. And then we'll move on to other forms of stoichiometry for gases and solutions in the weeks to come. All right, so study hard, practice this. It takes practice. It seems a little intimidating at first, but you can do it. It's just practice and you'll get good at it. All right, we'll see you on the next lesson.